Welcome, class. Today we're going to be continuing on into the 7.3, 7.4 area where we're going to be looking at triangle sums. All right. So let's actually switch to the latest pointer for right now. So what we're going to be doing with the warm-up is we're going to be looking for the angles that are congruent and try to find all the angles that are here. So we have 7, 3, and 2 are all 60. So if we're looking at that, we got to think of that Z pattern, starting here, down to here, over here. That means that 3 and those two are 60. So let's just go ahead and write that on it. So we know that this one is definitely 60. So okay, since we know those two are 60, how do we know that this one's 60? Well, 1 plus 3, these are the measurement, equals 180. Mind the ferocious monster in the background. So we have 1 plus 3. So 3 is at 60. Okay, so we have 1. Measure of 1 plus 60 is equal to 180. So if we just subtract that 60 off, that gives us 120. So notice that 3 and 120 plus 60 is 180. That must mean, if we're looking at this number 1 and number 2, that's also going to get that 180 vibe because 120 plus 60. I am sorry about that. We shall continue. All right. Anyways, so we know that the 120 is here, here, 5, and 8. So we get the 120 for the rest. So all the rest are 120. Today we're going to be dealing with triangle sums. So we're going to use lines to construct a polygon parallel to one another to solve problems and prove some theorems, and use sums of triangle measures of triangles to solve some problems. That's what we're going to focus more on. This is the second one. All right. So we're going to start with the warm-up. Done. We're going to look at vocab and have a bit of a discussion and have some classwork. So we have alternate exterior angles. That's what we were covering, as well as alternate interior angles the last few days. So should be familiar. Remember, alternate angles. That's that Z with the parallel lines. All right. So let's have a couple of easy to follow proofs. We have 710 and 711. This is directly from the book. So 710 states this. Through a point not on a line, as you see, point P is not on line B. There's only one line parallel to that given line point. So if looking at this line, there's a line up here, AP, that's parallel to B. All right. Triangle angle sum theorem. The sum of the measures of all triangles is 180. Measure of A, measure of B, measure of C is all equal to 180. So we just add those up, we get to 180. Let's go ahead and prove the second one. So right here we have a line CB, and we have the point A on the line. It's not CB, so it's parallel. So we have this BD line, okay? So to prove that the triangle sum to 180, we start out with the fact that AD, this one, is parallel to right here. This is given due to this symbol right here on both. Let's just go ahead and draw on the figure and make it a little more obvious. So, we expanded out the line CB. All right. Remember that Z pattern. That's saying that the 2 and the 5 are now congruent. Let's write that down. The measure of 2, the measure is congruent to measure of 5. Alternate interior angles. Likewise, we can say that the measure of 1 and the measure of 4 are also congruent using the same reason. alternate interior angles. Last thing we need to say is the measure of 3 is congruent to itself. Well, 5 is equal to 5, and that's just the reflexive property. So that might be something that's a little bit more vague, but is a property we can use. Okay, so 4 plus 3 plus 5, that makes that straight line, so we know that equals 180. So that's angle sum. Now, remember how we said 4 and 1 are interswitchable, 3 and 2 are interswitchable, so let's just switch those out. So we're going to substitute 4 for 1 and 5 or 4, 2. And that equals 180. By substitution, we have just proven that any triangle will equal 180. So let's have an example about what we're actually looking at here. There's a couple of different ways to go about this. Right now, we're asked to add values of x and y in this figure. X is a lot easier to get to right off the bat because we literally have 3 angles to work with. We have the x, the 96, and the 35. Since it's a triangle, we're going to have that equal to 180. Sum up the other two, so we have 35 plus 96 gives 131, plus x is 180. Then we just subtract the 131 from both sides and get x is 49. So let's go and put that 49 right here. Now, we have 2 different ways to go about this next one. There's 2 different ways, as I said. Sorry. So if we're going to use the x, we're talking about the big triangle as a whole. We're going to use the 49, the 77, the 35, and the y. But right now it's x, but we can plug in that 49 and go from there. Then we just sum up like we just did. 77 plus 35 plus 49 is 161 plus y is equal to 180. Subtract 161, and we get y as 19. There is one other way. Go ahead and give it a pause. Try to figure it out, and we'll go from there. Entails the smaller triangle and that 96. Knowing that this 96, we can, in this spot right here, make 180 if we just subtract the 2. So 90 minus 6 is going to get us an 84. Because 180 minus 90 gets us 90. 90 minus 6 gets us 84. Then we can do the same thing. 77, 84 up here. Done. Okay. Here's another example that we can look at. Okay. So, what are the values of x and y in this figure? So we're after this y and this x. The x is a lot easier to solve for because we just need to be together right here. So for the x, we just simply add 59 to 57 and then deduct that from the 180. So 116 plus x is 180. Subtract the 116 from both sides, and we get x is 64. So vertical angle theorem says that this 64 carries right on over there. We know that x is 64. So now we have 42, 64, and y. And we do the same thing. 106 plus y is 180. Subtract 106, and y is 74. Done. We're going to take a pause here and jump into the OneNote at this point and go through what we have here. So, just a little bit. As you see, we can go through this example and go through this one. And have a couple practice ones, but you probably will need some help getting through this one, but we have all the information needed to go through these first few. So, we'll jump through these 2, and then we'll go back to the other slides. All right. Sometimes it's mine. So let's go ahead and read through what we have here. So exterior angle. So triangle sum theorems, all triangles summed, also known as add to 180. For the diagram, measure of A measure B, measure C equals 180. Measure for the exterior angle. This is something that we'll cover here in a little bit. The sum of the two opposite, A and B, also known as remote interior angles. Measure of A, measure of B, so you add those, so you get the measure of B. Why does this work? We'll look at the two equations. Measure for the interior triangle, A, B, and C equals 180. The straight line, D. So this one equals 180, as does this one. So we have those two equaling 180, so we can set them equal to each other. Because C plus D is equals 180. So we have A, measure of A plus measure of B plus measure of C equals the measure of C, measure of D. Notice that we have this measure of C in both areas. Right here and right here. So we can just subtract it. As you see right here, we're subtracting the measure of C from both sides and simplifying to get what we have. So that's just kind of going through the nitty gritty. We'll see a more visual example here in a bit. But let's start with right over here. And apparently I am drawing with the tablet. Sorry about that. Okay. So for this very first example, let's go ahead and look what we're after. We're just after that X right there. But we have to work with a 79 and a 41. So what we're going to do in this case is go ahead and sum everything to 180. We're going to have that 79 plus 41 plus the X is equal to 180. So 1 plus 9, that's going to get us a 0. We carry that 1 up there. So 7 plus 4, it's going to be 11 plus 1 is 12. 120 equals X plus 120 equals 180. Subtract the 120 from both sides. And we have X equals 60. So this first one we have X is equal to 60 degrees, and we're pretty much done. You can do a quick little check. 60 plus 41, that's 101. 101 plus 79, that's 180. Good to go. Now, for this next one, notice we have a couple different things to look at. We have W, we have X, and we have Y to figure out. The easiest one, if you look at it, using the info we have, is actually W, because we have this and this. It's just like putting together pieces of a puzzle. Because we have these two to work with to get that W. And then the W, which actually can go right here, but can also be used to figure out the X. So both are figure outable from that W. So once we get W, we can actually go both ways. Might as well just grab the X along the way and then continue on to figure out the Y. So let's start with that. Let's start with that W. So we have 42 plus 85 plus W equals 180. So 2 plus 5 is going to give us 7. 4 plus 2 is going to give us a 12. So 127 plus W equals 180. Subtract that 127 from both sides. So we get W is now equal to 53. All right. So we know that W, we'll put that right up here, is equal to 53. We already know what X equals. Why do I say we already know what X equals? It's because we already figured that out right here. W plus 127 equals 180. So if we were just looking at 180 minus 53, we would get back to 127. So 127. So we also know that we have a 53 right here. Now we can go ahead and figure out y. 88 plus 53 plus y equals 180. Notice that we have an 88 right here and a 180, so let's just take care of that slightly right now, okay? So if we just think about it logically for a second. Half of 80 is 90. 88 is 2 less. So we can say this, do shorthand, 53 plus y is equal to 92. Notice all I did was subtract 88 for both sides. 180 minus 88 10, 2, 17 minus 8 is 92. Now we can just go and subtract the 53. This is a different way you can go about things. And you'll get the y term. 12 minus 3 gets us a 9. 8 minus 5 gets us 3. So we have 39 for y. And we're done. We'll have a look at this one a little bit later. These should easily be solvable at this point. But let's jump back to the OneNote at this point. All right. So, triangle exterior sum. We already talked about this slightly, and we proved why this actually works. Measure of each exterior angle triangle equals the sum of the measure of two remote interior angles. As you see, remote's right here again. That's why we talked about everything. Measure of 1 is equal to measure of 2 plus measure of 3. So what's the value of x in this case? All right. Notice that we have two remote interiors, so all I have to do is just add them together. So bring those 54 and 57 over, and then we're just going to have those add to x. So 54 plus 57, 7 plus 4, it's going to get us 11. 5 plus 5 plus 1, that's going to get us 11. 1, 1, 1 equals x. Done. Now, notice that it's slightly different for this one. Where what is the value of x in this figure? We have the exterior, and we have an interior, but we have a missing interior as well. So x something plus 49 is 104 is what we're going to be getting. Now, from here, we just simply subtract 49 from both sides. By subtracting 49, we get x is 55, and we're done. So we're actually going to jump over here and have a look at this one, and call it good. So, go ahead and give it a pause, give this one a shot, and we'll go from there. Welcome back. All right. Since we're trying to figure out what our x term in this case is, notice that we have x all throughout. But this one we'll highlight in yellow, actually, will be the one that's equal to the rest. So we have the 8x minus 11 is equal to 5x plus 2x plus 6. And we can also figure out what these x values are and go from there and figure out what the degrees are. I think we'll also have a look at that as well. So first things first is we need to gather these like terms over here. So we have 8x minus 11 equals 7x plus 6. All right. I can still stop. I just want to make sure about that. Sorry about that. So at this point, we want to look at the fact that we have a 7 and an 8. Both are positive, so we want to move the 7 over. So we're subtracting that 7x from both sides. Just getting us a solid x minus 11 equals 6. Add the 11 to both sides. X equals 17. Now, if you want to figure out what all those different angles are, 8 times 17 minus 11. So 8 times 7, well, 8 times 7 is 56. 8 times 1 is 8. 9, 10, 11, 12, 13. Minus 11. So now we have 125 for over here. That should make things pretty easy at least, because if we figure out what one of those are, we can just deduct that from 25. So let's look at the 5. 17 times 5. That's simple enough. 5 times 7 is 35. 5 times 1 is 1, plus 3 is 8. So we have an 85 down here. So notice that we have two different ways. We could plug 7 in to 2 times 7 plus 6. Or we could subtract 85 from 125. Let's do that way first and then just prove that it works the other way as well. So 125 minus 85, well, the 5's cancel, and so we see that we're going to be left with 12 minus 8, which is 4, and a 0. So we're expecting to get a 40 here when we plug that in. 17 times 2. Well, I see a 14 and a 34. Now we're going to add 6 to that. 40. Done. All right. So that's what we're working on today, and I hope you guys have a wonderful one. Thank you for